Okay, so today we are going to start our module number 5, and that is our static routing. Okay,
Okay.
so same here. This is our today's topic. We'll try to cover it, but mostly the static routing is divided into two sections. Like maybe we'll complete today one part, and the next class will be because it's two. Okay, one is basic part, and second one is
Yeah.
advanced part. Okay,
Okay.
okay. Now. So first of all, what is routing? This we already know, but we are just revising it. So routing is the process that forwards packet from one network to another network. The first thing. Second is routing is used to create communication between different unreachable networks. Third is it also choose the best path from routing table to reach to the destination.
Yeah.
Okay, and this is our scenario. Whenever any packet comes to router, if router has a single exit point, router will directly forward. But if router has multiple exit points, so at that time router manipulate, sorry, I'm saying manipulate, uh, negotiate and find which one is best. Okay, or and due to some best condition, it will find the best path and then it will start forwarding the packet from that one. If all algorithm and condition is same from this way and this way, then router 1 will do load balancing, right?
Right.
Okay, so as we know that yes, we have two type of routing: interior gateway protocol and exterior gateway protocol. So first of all, we are going to work with interior gateway protocol, which are static routing, default routing, and dynamic routing. Okay, so here what I told you that we have two type of routing protocols. Interior means the protocol which is working inside the organization, and exterior means the protocol which is helping you to communicate with the different organization routing protocols. Okay, okay, after that, the interior gateway protocols have three types: static, default, and dynamic. So static is what? Static is a manual routing where you have to configure everything manually. Okay, like if you want to go to
Which
any
lesson?
yeah,
We have finished this lesson the last day. The lesson 4. We have finished it.
no route. Did we completed the routing?
Yeah.
No, static.
Ah,
No,
no, no, no.
the introduction
It's
was
not
there.
this.
Yeah, introduction was
Ah,
there.
okay, okay,
Okay,
okay, okay. It's not this.
yes, okay. So we, I hope you know about these things because I have already explained, right?
Yeah, yeah, yeah.
Okay, so now we already know about the types of routing: static, default, dynamic. So in the last class I have explained you when we have to use static, when we have to use default, and when we could use dynamic, right?
Right.
Okay, so now let's come to know about static routing. Static routing is also known as non-adaptive routing. Means in static, the whenever you configure static routing, so router do not exchange the information from one router to another router. No exchange. Okay, in this technique, administrator configure the routes manually, and it create the path to reach the destination manually, and it creates the routing table manually. Okay, and so what here is saying that whenever in administrator wants to or create a routing table, so that destination must be reachable. Okay,
Okay.
then the communication will take place. Okay, now static routing table is created, maintained, and updated by network administrator manually. This provides a granular level of control over routing. Means full control. Full control means you know how your packet is moving from your router to destination.
Yeah.
But it is impractical for the large network. For a small network, it's okay, but for large network, it's not recommended.
Yeah.
Static routers do not share routing table with its neighbor. Static routing does not provide fault tolerance by default. Okay,
Okay.
you have to create, okay, that how fault tolerance. So that comes under floating static route, means in advanced static routing. Okay,
Okay.
static routing has one administrative distance which is 1. Okay,
Okay.
now some advantage and disadvantage. Advantage is what, that it has no overhead on CPU. Okay,
Okay.
means CPU do not do any kind of calculation because it is already predefined and kept in the routing table. Okay, and
Okay.
CPU is also not pre-calculating the path every time. It is already there in the routing table and it is forwarding according to that one.
Okay.
Bandwidth. Why in this static routing there is no bandwidth utilization? There is data bandwidth utilization, but not message bandwidth utilization as other dynamic routing protocols use. Like if I'm talking about RIP, EIGRP, OSPF, apart from sending data, RIP, EIGRP, OSPF, they also send some kind of messages to neighbor routers like hi, hello, how are you, like these kinds of hello. So some internal routing messages are also exchanged between neighbor in the dynamic routing protocols, and though those messages utilize the bandwidths. Okay, but
Yeah.
in static routing there is no any kind of message exchange. Like suppose if you are using RIP and I'm using RIP, so my router will send hello to you in every 30 seconds, to just to keep finding that you are alive, you are connected in the network, you are not down. Okay,
Okay.
yes. So these type of messages are sent in the dynamic routing but not in a static. That's why one benefit is this one. One second benefit is security, that yes, you know how the to whom you want to communicate and how you want to reach to the destination. But in dynamic, these how your packet should reach to destination, that is not predefined. It is automatic via routers and topology. Okay.
Okay.
Problem. Disadvantage is what? Disadvantage is, yes, large, for large network it is little bit difficult for the administrator. Okay, and if there is any downtime in the network, or if any cable is broken, or maybe if any router is down in the middle of the network, so administrator must have good knowledge of network to troubleshoot and find the problem. Okay, and one more
Okay.
problem is there, that if the connected link is down, okay, automatically the information what you have kept in the routing table regarding that interface will be removed automatically. We'll see these things. These are some technical terms. We'll see one by one. Okay.
Okay.
So these are some configuration. We'll come to know. If you are configuring a static routing, so we have three methods. Okay, to configure a static routing. Okay.
Okay.
Now let's configure a static routing. Open project static routing lab one. Okay. So this is our lab. Okay. In this lab, first see how you need to configure the lab. Okay, so I have written the steps. Step number 1, design and connect your network. Understood?
Yeah. Okay.
Design and connect your network means design how the topology is connected, how the switch is connected to router, how the PCs are connected. Okay, first thing is this one, design. Once the
Yeah.
designing is completed, Then start all the devices. Okay, once all the devices are started, then you have to click here on this ABC. Okay, this one. Okay,
Yeah.
why we are clicking on this ABC? To get the port number, okay, or interface
Yeah.
number. Okay,
Yeah.
okay, now you have to click here to get a console of all the devices. Okay,
Okay.
now second is configure IP addresses on the devices. Okay, so see here how it is connected. PC1, PC2, then router 1. So you can see here PC1, PC2, then router 1, then router 2, then PC3, PC4. Okay, now we'll
Okay.
come to router. Okay,
Okay.
so here, as always keep in mind here, as we are using /29. Okay, so my
Okay.
question is, how many IP addresses will be there in the LAN? Now tell me if it is /29. My question is, now you tell me. And
Mm,
if, because see, and here also in this LAN also, if it is /30, see, you have to understand, if router is connected like this, see, if you are connected here with this port, mm, okay, so this is one network. Okay,
okay.
okay, so in this network, it's a point to point link, right?
Yeah.
Okay, so serial link is always known as point to point link. So in this point to point link, if I'm using /30 /24 slash whatever, okay, so
Yeah.
you must know that, okay, how many IP address is there in this LAN? Because see, you are a network engineer, right? You have to save IP. You cannot waste IP address. Are you understanding? See here,
Yes.
if I will use like this /24, how many IP address will be there in this network? 256. Okay, now tell me, do you have 256 users in this network? Only two. So why should I waste my
Okay.
IP address? That's why here you have only 4 IP address. Okay, here you will
Okay.
have 4 IP address. How? 12.1.1.0, 12.1.1.1, 12.1.1.2, 12.1.1.3. Okay,
Three.
okay, now tell me the first one is what?
The first one is 12.1.1.1.
That the first IP is known as what? Network ID.
Network ID.
You know, or are you okay, now tell me. See, the first one is network ID. I cannot use this IP address, right?
Right.
First IP I can use, second last IP I can use. Okay, but
Yeah.
broadcast IP I cannot use. That's why
I
only two
cannot
IP
use it.
address is usable in this network. So it's okay, fine.
Yeah. Okay.
Now here, as it is /29 here, so how many IP addresses will you will have in this network? I know that yes, you can use
Six.
three, one,
Six.
two, three, but how many IP address will be there?
Six.
For sure.
Yes, because we have three. We have eight. in which you cannot use the first and the
Yeah, okay.
broadcast.
6 usable IP, right?
Yeah.
Okay, very good, very good. Okay, that's I was asking. Good. So here I will come to router 1. So router 1 have how many interface?
Um,
Two interface, serial 0
two,
by
two
0 and
interface.
F0 by
And
0.
the first,
Okay.
yeah.
Can
Okay.
I make more uh, visible to our scenario? See how you can make. Come to your option, then go to edit default session. Here you will come to advanced, not edit default, advanced, not here. Option, edit global option, advanced, appearance, advanced here. 200, normally it is, normally I use 207, so if I'm making it 197 or 195, let's see. Noise okay, let's see. Now is more visible, right?
Alright.
Okay. So router 1, conf t, IP address 12.1.1.1. Is it okay? Wait.
Okay.
No, wrong. See, I'll come here to router 1, then interface serial 2 by 0, right?
Like 0.
Okay, sorry, it's wrong interface. Serial 0 by 0.
0 by 0.
IP address is 12.1.1.1. No shutdown. Okay, so one interface is completed. Now I'll come to interface F0 by 0.
By
IP
0.
address 192.168.10.1 I'm
Okay.
using for PC1, 2 I'm using for PC2.
For
So
PC2.
you can use any IP from 3 to 6, right?
Right.
Yes, so I'm using this 3 and then subnet mask. So 29 subnet mask is 248 and then no shut. Okay,
Okay.
exit and then save the configuration. Now come to R2. Okay, after saving always verify. After saving you write here, so IP interface brief exclude unassign, always verify. Yes, the IP what you have configured is okay here. Now come to R2. Now conf t interface serial 0 by 0 IP address 12.1.1.2 no shut, then interface F0 by 0 IP address 192.168.20.3 248 no shut, exit, so save, then so IP interface brief exclude unassign.
Interface.
So IP interface brief. Okay. So IP is configured, and you'll see the PC IP address. How to configure PC IP address? Very simple. See IP 192.168.
Sorry.
No, yeah. IP 192.168.10.1/29 and gateway is 10.3, like this. Okay.
Okay.
If you want to save, you can save it. PC2 IP is 10.2. Gateway will remain same for everyone in the network. Save. Okay, PC3. PC3 IP is
20.
20.1, right?
Yeah.
And PC4 IP address is 20.2.
Dot 2.
Now, if PC1 wants to communicate to its neighbor 10.2, yes, no problem. PC1 is communicating. But once PC1 will try to communicate to another network person, 192.168.20.1, no communication. Router 1 is saying that no, I cannot reach there.
Yeah.
Okay. So why router 1 cannot reach there? See here. So IP route no reachability, because router 1 is saying that please I don't know 20 network. So can you
Yeah.
please provide me reachability? So for that you need to configure routing. So you'll come here conf. Okay. So routing can be performed in three way. Okay. So the
Yeah.
first one is you can configure via next hop. Okay. So
Okay.
let me show you what is how you can configure via next hop. You can come here, simply type IP route. I want to reach 192.168.20.0 network. The subnet mask is 248, but I know my neighbor IP address. So okay, now tell me, R1 have one neighbor R2, right?
Right.
So R1 has one neighbor R2, and what is the IP address of R2? Because see, R1 is connecting to R2 via which interface?
12 1 serial
Interface
0.
number, serial 0 by 0, right?
No.
And what is the IP of that serial 0 by 0?
The IP can be 12.1.1.2 or
No, here I
12.1.1.
have configured 12.1.1.1 and here I have configured 12.1.1.2.
Yeah.
So the IP is 12.1.1.2.
112.
Yes. So here you have to write the R1 neighbor IP address.
Okay.
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 Okay. Now if PC1 is trying to communicate. Now see, when you have configured this one and if you are checking the routing table, you'll see yes, R1 will say yes, now I know where is 20, right? But
Right.
if PC1 will try to communicate, see now PC1 will get different kind of message. Request timeout. Earlier,
Yeah.
R1
Okay.
as a gateway, R1 was informing to PC that yeah, my friend, I'm not reachable. Now, when the reachability has been created by R1, now R1 is not giving this message, someone else is giving this message. Okay, now you are getting that 20.1 is not reachable, means it's timeout, means when you are sending packet, it's not reaching to that network.
Yeah.
But your packet is, see, your R1 is dropping, R1 is sending your ping packet. Okay, R1, because now R1 know where is 20, so R1 is sending ping packet to R2, but
Yeah.
R2 is not replying back. Why? Because see, you must have to configure a reply path. See, let me show you one thing. You just run here debug IPIC. Now see, you send ping packet. See, ping packet is coming here. See, someone 10.1 is trying to communicate to 20.1, but it is unreachable. Who is unreachable? 10.1 is unreachable. Why? Because see, for R2, so IP route R2 is saying, my friend, I am getting your packet. Okay, and
Okay.
see, when you are sending packet coming here, it's coming here. R2 is sending here. Okay, but when
Yeah.
reply packet is coming to R2, R2 is saying, okay, now tell me here when this ping packet is sent via R1. Okay, what is source? What is destination? Tell me. When the ping packet is sent from here, source is what? Source is 10.1. Okay, destination is
Okay. Is 10, destination is 20
20.1, right?
dot one.
Yes,
Yeah.
so it's coming here. Okay, now when this PC3 is replying, okay, ping
Okay.
reply, okay, ping reply. So at that time, destination is,
Destination is 10.1.
yes, destination is,
10.1.
yes,
The source, I think.
yes,
The, s-
destination is 10.1 and
yeah.
source is
20.1.
20.1, right? Okay, so when this packet is coming here to R2 and R2 has to send the ping packet reply to R1 for 10.1 network. So R2 is checking his own routing table.
Yeah.
Let me first on all to stop the debugging. So IP route. Now tell me, do R2 know about 10 network?
Mm,
No. R2 do not know about 10 network, right?
right.
Yes. That's why R2 is not able to send the reply packet. So if you want
Yeah.
this to be happen, so you have to configure reply path from both side like IP route. So IP route. See, now reply path is there, right? And now if PC1 will try to communicate, now see communication is happening.
Okay.
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 So this is called your static routing with next hop address.
Yeah.
Okay. Now there is other option also to configure with exit interface. Okay, exit self exit interface. So for that you have to delete that older configuration. So you have to come here conf t. So if you want to delete any configuration, you just write no in front of the same command.
Yeah.
Okay, r1 is removed, r1 has removed the configuration. Now come here also type no and it's removed. And now if you check here, do show IP route, do show IP route, it's not there. Here also if you check, do show IP route, do show IP route, it's not there, right? And again same problem is there. See, no communication. If you want to create communication, now see another command. See IP route. Okay, 192.168 dot 10 sorry 20 255.248 and next see self exit interface serial 0 by 0. That's it, very easy. Come here, IP route 192.168.10.0, subnet mask is 248 and exit interface is this one. And if you want to check, do so IP route, yes, it is in the routing table. You can see here it is in the
Yeah.
routing table. Okay, and here also
Okay.
it is in the routing table. And once it is in the routing table, if you come to PC1 and try to communicate, it's communicating. Okay,
Yes.
now one problem came, maybe if it is listed here or not. Okay, let me show you. Yes, recursive lookup. Yes, yes. Okay. So now problem. See, if a recursive lookup is what I can show you. Just a second. Okay. So here. So here in this session we have seen two type of uh, static routing with next hop and with exit interface, right? So we have
Right.
used this next hop command, okay, and then we have used this one. After next hop command we have verified the communication, right?
Right.
Yes, after verifying the communication we saw the exit interface configuration.
Yeah.
Okay, through exit interface we just configured this one, just exit interface, and in the previous one we configure as a next hop IP address. Okay, yeah,
Okay.
R1 will write the IP of R2 serial 2 by 0, and in
Yeah.
exit interface you have to write your own exit interface number, not IP, nothing. Okay,
Okay.
this one. Now one problem came. Okay, reverse
Okay.
lookup. Okay, reverse lookup means multiple time lookup for the same destination. Okay, see what is multiple
Okay.
time lookup of the routing table for the same destination. Now if you are coming here to PC1 and if you're trying to communicate, you see the communication is working, no problem. But what is
Yeah.
happening behind the scene, that if you're checking here, so IP route. Okay, so you can see here that R1 is saying that yes, I know 20.0, okay, through static
Yeah.
routing, and my neighbor is 12.1.1.2, right?
Yeah.
Okay,
Right.
now so any packet is coming to router 1, router is saying wait, I know 20.20 20.0 network, and it is connected to my via neighbor. Okay,
Okay.
okay, but let me recheck again that to communicate 12.1.1.2 I should send packet via which interface, because I have two active interface, serial 0 by 0 and fast 0 by 0. Understood?
Yeah.
So for that, router is running some kind of algorithm, this one. So IPCF Cisco Express forwarding to that destination. So he's saying that now see this is the real routing table. See, next hop means I know to reach this 20 network I have to reach via my neighbor, but I don't know where is my neighbor. See here, my neighbor is connected via which interface is not detailed here. See here, it's not there, right?
Okay.
So
Okay.
I have to re-look up. I have to re-look up and find whether my neighbor is reachable via which interface. Okay, so you have to say
Okay.
okay, serial 0 by 0. Okay,
Yeah.
so
Okay.
it's doing two time lookup to reach, to send one packet. So if PC1 is sending how many packet, 1 2 3 4 5, so your router is doing 5 time recursive lookup. Okay, if your
Okay.
PC1 is sending this kind of message, 100 100 packet. Okay,
Okay.
so you can send continuous packet like this for testing purpose. So your router is doing 100 time reverse lookup, recursive lookup, that is known as. Okay, but we
Okay.
don't know because see it's a behind process running inside the router. So processing is high, because see for a single user request, PC1 request, your router is doing 100 time lookup. So you can imagine that inside the network if you will have 100 PC and all those 100 PC will send 10 packets, so you can understand that how long your router CPU will utilize, right?
Right.
Maybe sometime it can hang also. Okay,
Yeah.
so Cisco said that okay, no problem, let's come with another process which is known as the combination of both next hop and self exit interface. So you can come here conf t and you say this with this command, no, and now you configure the another routing like this. Okay, so you write here self exit interface and your next hop address like this. Okay, and now see,
Okay.
so IP route. Can you see the difference between this routing table? Now see, in this routing
Yes.
table all information is there, right? Can you see here? Via neighbor
Yes, sir.
through this interface, and
Okay.
but in the previous one it was not like this one, right?
Yes.
Okay,
In
and
the
now see the
previous one, we
benefit.
have not the serial.
Yes,
Yeah, yeah.
and now see the benefit if you're running this C. Can you see here any kind of recursive information?
Zero dependency.
Yes, but earlier there was some kind of recursive information, right?
Right.
Yes. So this is the benefit why. So companies they use this one. Which command?
Okay.
This command. Combination of this. Okay.
Okay.
But see, normally we teach this type of information in CCNP.
Yeah.
Okay. Okay. So, and we have verified the recursive lookup. Okay. See
Mm.
here I have written this command. Okay. So finally you can use this both command. Okay. This combination of self exit and next hop address. Okay.
Okay.
Now see. Now if you will have network design like this, maybe your router is connected with another router via point to point
Yeah.
link, right?
Right.
Okay, and your router is connected to another neighbor router via broadcast link, the
Okay.
fast ethernet or ethernet link, right? So in that
Right.
condition which command should be used, which static command? So Cisco is recommending that if your device is connected to another router via point to point serial link, in that
Yeah.
condition you can use this one, self exit interface. Okay, but whenever it is
Okay.
connected, yes, but whenever it is connected via fast ethernet link or ethernet link, so you use combination of both. Okay,
Of both.
yeah, combination of both, self exit and next hop address. Okay.
Next.
Yes.
Okay.
Okay, so this lab is for you, simple static routing. So in this method you can use any routing. Okay, next hop or self
Okay.
exit interface, no problem. Okay, so this is for
Yeah.
you. Okay.
Okay.
Okay, this is also for you. Okay, now see,
Okay.
this is for you, but in the next class once you will complete this one. Okay, so in the next class I
Okay.
will explain you, then I will move to advanced one. Okay, this is
Okay.
multiple static route, means now we will be moving to advanced one. So advanced one we will, means from this lesson. Okay, in our next class we will start from here where we will be talking about IP load balancing and path redundancy. Okay.
Okay.
Okay, so till here you see how many labs you have to do by your own. One lab, two lab, and three lab. Okay, but
Yeah.
once you will complete this lab number 4. Okay,
Okay.
before starting our next session I will be explaining this lab. Okay,
Okay.
that how it should be correctly configured. Okay, I know that you will make a
Okay.
mistake, I know, that's why I'm not explaining now. Okay.
Yeah.
Okay, so once you will configure and you will tell me, and you will show me that yes sir it's communicating and how you have configured. Okay, I'll ask some questions, then you will say according to your answer I will know that yes you have configured it. Okay, then I will show you
Okay.
how to configure like in a real manner, like how organizations are configuring this type of network. Okay.
Okay.
Okay, so this one I think, yeah, as I told you, we'll move advanced will be our next session. Okay.
Okay.